Okay, good morning. Okay, so I think we need to start now. So last time I didn't finish this introduction to MECH. Let me just quickly finish the presentation of this introduction MECH. Then we talk about our today's main topic is mechanism of machinery. Okay, so we already briefly talk about this introduction MECH. Right? First is what is MECH, right? And I'll talk about why it's so important and popular. It's a lot of business, and then talk about history, and also the current and future application, and talk about this kind of basic idea of micro pressure sensors, accelerometer, micromirror, and inkjet print head. And these are all very common in your daily life, right? Like a pressure sensor, accelerometer is most likely in your smartphone, and then digital micromirror actually is very common now for computer projector, and inkjet actually also very common. Okay, so here I just show you. Of course, today I just quickly finish this remaining part of this lecture, so that we basically again quickly show you about micro machine is a very important topic, right? It's a micro. We try to do fabrication of this micro machine using IC industry or similar industry, and the size range from micrometer to millimeter. All right, and again, it's a system integration, integrate sensing, actuation, computation, control, and communication and power. Okay, and last time we typically show you about the typical application of this MECH sensor, right? In 1990, one of the main application in the automotive industry, like a pressure sensor and accelerometer. Pressure sensor is for use of the engine of the car, right? And then accelerometer is used for airbag system to increase the safety of car. And then, of course, now this kind of sensor become so common in your smartphone. Right? Again, your smartphone has at least 10 sensors. Okay, you have MECH 3x MECH accelerometer, gyroscope, 3-axis digital magnetic sensor. Right? This is a compact, right? Magnetic compact, and then also you also have a touch sensor, right? Your finger touch sensor, and also proximity sensor, and things. Right? So this become one of a very important application now, right? So that you see, so that here most likely in your smartphone you have accelerometer, magnetometer or magnetic sensor or digital compass, gyroscope, ambient light sensor, proximity sensor, pressure sensor, and touch sensor. And so, of course, some of these smartphone have fingerprint sensor, right? And then for iPhone 6, 7, and then iPhone 10 have what? This kind of special infrared camera, and then with V-cell. V-cell is a 3D like sensing, so that you can try to do face recognition. And of course, also a MECH microphone. Every smartphone has at least more than one microphone. Why? Because with array of microphone with additional sensor fusion program, we can improve the performance of this kind of voice recognition, and then connect to AI. I think all of you may have tried to use Google's the AI function or this kind of Siri, right? So that Amazon Alexa, so that all this become so common, right? Basically your I don't know if you have seen this kind of Amazon Alexa, or in China Xiaomi Yingxiang. Basically, this is an array of MECH microphone with some sensor fusion program, and also connect to the wireless communication to the cloud server, and then to the AI, right? So that you can have a lot more application. Right? After smartphone application, and then MECH, it will be also important for this kind of IoT device. Okay, and again, so now we are in this transition, right? It means not smartphone application, IoT, Internet thing, so that IoT is encompassing. I mean, we have a lot of this sensor. Training sensor will be used in all kind of application: smart building, smart car, and then smart manufacturing, and all this requires sensor and AI. Okay, And then, of course, as I show you last time, so that I have a project with MIT, $10 million project to work out how we can look at the Siemens man thermal flow sensor, multi-sensor, temperature sensor, humidity sensor, and then look at energy sensing and human thermal count sensing, and then also work with MIT professor on smart window and also AI, so that we want to build this kind of smart HVAC system to save energy, right? So this is important for Hong Kong. And so in UST, actually, I don't know, do you remember how much our UST had to pay for this air conditioning, like the bill and also electricity? Any idea? Do you know how much we pay for this kind of air conditioning, the bill? How much? This is a big money. How much USD pay we spend for this kind of utility, right? HVAC and also electricity, the bill. Any idea? Electricity, the bill. Every year. Any idea? Oh, sorry, well, I told you, let me show you. Any idea? I told you the total utility cost for UST to pay is about 40 to 50 million Hong Kong dollar. Okay, I mean this is 40 million to about 50 million Hong Kong dollar per year. Okay, so if we can really save about 10 or 20% of this kind of energy cost, right? And then that is big money, right? If you save about 10%, 10% is almost 4 million Hong Kong dollar. Do you understand? So that's actually, so this is very important. That's why I think I have this kind of big project with MIT. Okay, and anyway, of course, we also have. I'll quickly show you about how the pressure sensor works, right? And basically, it's a diaphragm, and then once the pressure applied, it causes deformation, and then once you have this kind of capacity sensing, capacitor, and then you can change the gap, right? And then change the gap, and then you can have input pressure, cause deformation of this mechanical structure, and then change capacitance, and then from capacitance change to output voltage, so that in this case you can make sensor. Another thing is we can also try to put this kind of make a micro piezo resistor. It's a resistance, but it's sensitive to input pressure. So once you have this applied pressure, and then we change this pressure will change resistance, right? And then we can also do this kind of sensing, right? That means input pressure and change resistance, and then convert resistance into voltage output. Then we can make the pressure sensor, right? So this is the basic idea. And of course, in reality, all these main sensors require additional integrated electronics to do this kind of signal processing, like amplification or additional digital signal processing, and then so that become important thing. Okay, and of course, we'll also quickly show you about accelerometer. Accelerometer is a sensor, right? To measure acceleration. So the sensing idea is very simple. Basically, if you have this kind of mass spring, micro mass spring system, right? So here we have a put mass, and then this is spring. So that once you have input vibration, and then what happened? Input vibration can cause deformation of this micro spring. Okay, and then in this case, if we can convert this deformation of micro spring into electric signal, and then we can try to measure this kind of acceleration. Okay, so that is I think the basic introduction how we can make this kind of accelerometer. That means input A, and then we call deformation. Deformation maybe that of the spring, deformation of the delta L, and then we try to into voltage output. So this is the basic way we can try to make this kind of pressure sensor. Of course, in reality, actually, our micro mass spring system would be, you want to make a more practical design and make a product, you need to have learn about all the UG mechanical engineering, sound mechanics, and dynamic. Like you have a special type of a spring, micro spring, and make a more reliable and this kind of mass spring system. And we also have a pair of this kind of capacitor, right, to increase the sensor output, right? So this is becoming important thing, okay? And let me check here. And of course, we also show you about in real this kind of mass accelerometer in your smartphone. Basically, you have not only the micro mass spring system, you also have this kind of on-chip electronics, so that you can really convert mechanical input into electric output. Okay, so again, nowadays billions of sensors. Now this kind of mass sensor would be fabricated in smartphone, and then of course, as I told you, you can download the app, the free app, and so that you can try to turn your smartphone and then to measure to give you this kind of acceleration and in 3 directions, right? X, Y, Z, and also that is something you can. If a time, please try to download the free app, so that I think it would be interesting for you to understand our thing, right? You can download. Let me show you. You can download this kind of app. Please try to download the free app for your, right? This is a sensor kinetics. Okay. Now, so that this sensor kinetics is you know, for iPhone and also Android smartphone, so that actually you can use it. Okay, and in reality, this kind of micro mass spring is mass so small, about 0.7 microgram, and then also the feature size, the gap is also like a 1 micron, and input acceleration like 2G to this ADXL accelerometer, and then the deformation of the micro spring is so small, 5 nanometer. Okay, so, and of course, again, I show you so that now all of you have smartphone, and all the smartphone has this kind of mass accelerometer, right? 3-axis mass accelerometer and also gyroscope, right? And also for after iPhone 4, and then of course not only mass accelerometer, but also mass gyroscope. And gyroscope basically is another quite important sensor, right? It's based on this kind of mechanical vibration. Here you see, you have this kind of tuning fork, right? Your micro mass spring system, and then once you have vibration, electrically apply the force caused on vibration of micro mass spring system. Once you have rotation, your smartphone, and then what happened? What in this case, this interaction of linear velocity, this vibration, and angular velocity, and then in this case, it can cause this kind of coriolis effect, right? And then this effect would cause some deformation of micro spring, right? In this case, you can, if you convert the deformation of spring into electric signal, just like previous first sensor, right? Maybe capacitor sensing, and then I can make a gyroscope. So again, if you download this free app, actually, you see, basically you can see this angular velocity output, right? Not only acceleration, angular velocity, and also magnetic sensor. Okay, so that and here again, if you open up your smartphone, and then this is iPhone's PCB board, so that there's a little chip here is ST microelectronics 3-axis micro accelerometer. Okay, and of course you also have magnetic sensor, right? So that so actually, if you have smartphone, I think more than 99% of smartphone have this kind of we call the they don't call the magnetic sensor, they call barometer or altimeter, right? Barometer actually is measure the pressure in the air, right? In this case, I can look at the altitude, right? So that is become so common in your smartphone. Again, why we need this kind of thing? Because we need what? Navigation, right? If you use Google Map, and then of course GPS is one kind of sensor, right? Look at the XY coordinate, and then sometimes you have no GPS system, the signal. Then this kind of mass motion sensor and magnetic sensor will be useful for guidance control. So that's why now almost I would say 99% of smartphone have this kind of old sensor, right? And of course, we also digital micro mirror basically is array of the again torsional mass spring system, right? So that means you have this kind of again mass, and then you have spring. By torsion spring, once you apply the force, then you can cause deformation, but angular deformation, and then you can try to control the light, right? So you can use as a computer projection, right? That's a big important thing. And of course, this kind of main sensor not only used for smartphone, but also used for main gyroscope, and also this has become so common, right? And so of course, for all this kind of this kind of actuator, you need what? Not only pure mechanical micro machine, but also electronics, right? To control 1 million of this kind of micro mirror, right? So that you cannot have 1 million wire. That's why you have each micro mirror is some on-chip electronic to do this kind of control. So that become very important thing. Of course, this kind of digital DLP, digital micro mirror is also important for what? For those kind of LiDAR in self-driving car. Like I think many companies now they really try to develop this kind of micro mirror for this kind of LiDAR, like the MEMS micro mirror for this kind of LiDAR, MEMS LiDAR for self-driving car. I think this become if you have seen those kind of Google self-driving car, on top there's a very big rotating mechanical rotating LiDAR, but it's so expensive. In order to make this kind of MEMS LiDAR becomes cheaper, and for every self-driving car you have to use MEMS technology. Okay, that become very important thing. Yeah. And then of course, as I show you, inkjet is another important application for domains. Basically, is again based on micro heat transfer. You have a micro heater, and then you heat up in very short period of time, heat up the ink, right? And then it's just boiling water in, but it's in micro scale, so that once you can heat up the ink, and then the liquid ink will turn into vapor, and then you have generate a lot of this kind of pressure to push the ink out of the nozzle, and then it forms this kind of droplet. So that this is a electronic switch, also important to control not only one inkjet unit. You have array of inkjet, right? Do the high speed, high quality printing, right? So that become so important thing, right? Again, this kind of this is micro heat transfer, right? In very, very small scale, you have to in very short period of time, like 10 microseconds, you heat up, right? To say and generate some bubble, right? So then this is become so interesting, okay? And then nowadays, of course, you have a real array. Typically, HP or Canon inkjet, you have more than 6,000 micro machine nozzle with micro heater, and then so that in the case we can do the high speed, high quality printing. Okay, so you see, nowadays you really have a large number of this integration of micro nozzle in inkjet printer using the MEMS micro machining technology. Okay, and also actually this kind of micro machine is not only useful for this kind of consumer electronics, and also but also for what? Actually for biotechnology. So that in the past 20 years, people spent a huge amount of money to DNA sequencing. Traditional is a huge machine, I see. Okay, and in year 2000, people internationally have spent 2.7 to about $1 billion, right, to do the human genome project. It costs about big money and also long time, 11 years. And then gradually people come with some new technology, and like 3 years, 100 million, and then 454 company spend $1 million US 3 months, and then also gradually actually people really try to do micro machining, right, to make this kind of DNA sequencing device like Illumina, they call the flow cell. Flow cell actually, Illumina is one of a #1 company to make this kind of flow cell microchannel, microfluidic device for DNA sequencing machine. And of course, there are other company. There are many different ways people try to make this kind of micro machine, this kind of same microfluidic device for DNA sequencing. The latest one is Oxford nanopore. They really make the portable, okay, DNA. This is nanopore, right? Nano machine and nanopore DNA sequencing machine. Okay, so actually this is a product now. Do you understand? So that in the past 20 years, actually the cost of this kind of DNA sequencing reduced by almost 6 orders of magnitude, and it'll be almost much cheaper now. So that enable a lot more application. Okay. Again, so here I'll quickly show you how we do fabrication of these commands. In general, we have two processes. One is surface micromachining, another bulk micromachining. So that basically, surface micromachining, basically you deposit some thin film material, and then you do patterning, right? And then you do deposit another layer, structure layer, and then you do etching. Etch out this kind of severe layer, it can become freestanding microstructure, right? You can make a pressure sensor, a spectrometer, or gyroscope. Okay. On the other hand, you also have the bulk micromachining. Basically, use wet chemical, wet etching, and then you etch the bulk, the silicon wafer. Okay, and then it depends on chemical, right? Sometimes you anisotropic etching. That means etching of silicon depends on the direction of this crystal orientation, or if some other chemical actually is isotropic etching. Okay, so that again, I quickly show you about how we do this kind of scaling, right? So that here again, it's important, right? You understand about micromechanics, so that you're able to design this kind of micro machine for real product in a smartphone, in smart building, smart car, right? So basically, here, picking I show you one of interesting people we find out is stiction, right? Like in high school physics or UG, no, like physics, we understand, right? So once you have this kind of a big mass and then sit on this kind of ground, and then in this case, you have friction force, now will be proportional to the normal force, right? And then that is very interesting, right? And then if you turn this kind of big mass, now 90 degrees, this kind of friction force is still the same. But in micro scale, actually it turns out this kind of this friction force, it really depends on this the contact area. So that that is something very, very important, right? Again, the friction force is function of contact area. And then, of course, one important thing is for our micro machine to make a working device is stitching problem. So that there's a surface tension, right? Becomes so important. If you don't overcome surface tension, sometimes our sustained microstructure will stick on our silicon wafer, and then your device cannot move, right? So that is a big issue, right? In about old days, but now people understand how we can have a good design and do good microfabrication to overcome the problem. Surface tension, as I show you, it can be bad thing. I show you in previous one, or it can get good application, right? Basically, here I show you is surface tension can be good application. For example, surface tension driven microfluidics. So if you have a microelectrode apply the voltage on a droplet with some kind of electrolyte, some ion, and then we can electrically change the surface tension. In this case, I can make some micromotor, and of course, this can be used for many different occasions. For example, nowadays in a smartphone, right? How you can make a zoom lens. Traditional zoom lens is very big, very bulky, right? So if you use this kind of electrically control surface tension, control droplet, and then the company like Very Optics, and they want to make this kind of electrowetting based zoom lens for a mobile phone camera, right? That is something become important now. Yeah. And of course, in order to make a real good product, so that it's clear, you need to think about the market, right? If you must have a big market there, and then, for example, smartphone, the big market, right? If you're able to design and make this good demand sensor for smartphone, it's $1 billion business. It's not small at all, right? And then, of course, another thing is how you can come with a good design to replace the existing product, right? Or big bulky devices. That's important thing, right? So that you need to make sure that you have design can have improvement in cost, performance, quality, and reliability, and then you have chance to make a real good MEMS sensor, especially sensor for not only for smartphone, for other application, right? So of course, what's the future of this kind of beyond smartphone? I don't know if you have any idea. What's the this kind of billion-dollar business? IoT, as I said, sensor, it would be like we want to have install a lot more sensor in the smart building, smart city, smart car, and then we need this sensor, right? So that we also need what? VR, AR. I don't know if you have play with the VR game in smartphone, VR, AR, right? Even Google, I think that Google has this kind of VR, AR application, right? So that this will have another very big market. All the VR, AR, the kind of devices like or MR need this kind of a sensor, our main sensor. Okay, so this create a huge amount of the business in the near future. Right? Again, this will be this kind of at least billion-dollar business. No, okay, so that of course. Then next one we try to show you about to overcome the difficulty, and actually our main engineer we need to overcome about how to do fabrication, right? Micro machine and microelectronics. Sometimes if you do micro machine on microelectronics, then maybe your IC electronic have some problem, so that you need to think about this thing. Or you want to make this microelectronics on micro machine, right? Actually, both has a good and bad things, so that it's in general it's still not easy to make this kind of microelectronics integrate with the micro machine for this main sensor. But gradually, people do this kind of 3D IC integration will be more practical. If you do every fabrication in one single wafer, it's too tough. Okay. Anyway, so here at the moment, most likely those manufacturing facility in place usually is right on mature IC fab, right? Or a big semiconductor company, they can really spend a long time to do R&D for this kind of MEMS product. Of course, gradually still has some MEMS fabless company. They want to design about MEMS and then sell design to the foundry to do fabrication. For example, one example is InvenSense. Okay, actually I do have some collaboration with InvenSense. InvenSense in Silicon Valley. Okay, so this company is a MEMS fabless company. They have no fabrication facility, but they do design and send design to TSMC to make their TSMC in Taiwan. Okay, to make their product. Right, so InvenSense is one of the company to make a MEMS motion sensor in your smartphone. Okay. Again, in the near future, we have a lot more application for our sensor. Right? Not only smartphone, smart wearable device, smartwatches. Here I have smart watches and also the IoT device, Amazon Alexa, and also drone, your drone, smart home, autonomous vehicle, self-driving car, right? All the robots, right? Advanced mobile now, they have about at least 100 or 200 of this kind of sensor, okay? Oh, here's the InvenSense, okay? And then, and again, another important in the following 6 years, again, this is ideas come from the founder of the Cadence company in Silicon Valley, Dr. Paul Huang. He has his own vision with this kind of CMOS MEMS sensor, right? We can really enable another new generation of semiconductor industry. So integration of all kinds of sensor, right? At the moment, the most mature sensor in smartphone is what? Like your eye, right? The CMOS image sensor camera. And then you have a microphone. It's a year. In the future, we got additional sensor. electrical sensor, mouse, and electronic noise, and body touch sensor. Right? All these sensors will integrate with AI and then have an application VR, AR, drone, and robot application. So that is a big feature. If you're interested, you can try to look at YouTube lecture by this Dr. Paul Huang. He not only have one company for Cadence is IC design company, also for the media. For media, it's a MEMS microphone company consists with additional IC design and AI, and then so that this become very important in the following 60 years. If you want to, well, get rich, I think this kind of MEMS has a potential to go into $1 trillion business in the near future. Okay, and anyway, so of course, this kind of sensor is so important for smart manufacturing. TSMC is world #1 in the world to make this kind of IC for your iPhone, Google the TPU, and also the GPU, and many big semiconductor company, even Huawei also same design to make IC and MEMS. So actually they use, you see, in old day, all the machine in this semiconductor manufacturing plant, they have about 200 to 500 sensor. But after 2014, they have about 500 to 1,000 sensor in the machine, right? And a more advanced lithography system, right? Micro machining system is requires 7,000 of the sensor, right? And then again, so 12-inch fab, they have a generate 1 million data per second, and then use all the advanced, right? See, right? All the sensor data for this same smart manufacturing where what they do machine learning and then to optimize this kind of performance of this IC fabrication process. This people say this is one of the leading industrial 4.0 the system. Okay, that's why TSMC can be the #1 now, right? To do this kind of semiconductor manufacturing. Also, MEMS fabrication. So that is something important thing. Okay, here I quickly just finish the part. Basically, so that MEMS is an important area, and then so that it will enable a big business, and then hopefully some of you will be interested in go this field. Again, I've been working on MEMS research for almost 20 years, so that at this moment I joined this kind of a big project like Hong Kong Inner Air project with UC Berkeley. If you're interested in work on this kind of MEMS UG project or want to study for PG for this research on it, please try to email me if you want to work on this area. Okay. Again, this is the end of this part. So do you any question? Huh? Any question about this part? Any question for this part? Again, if you want to interesting about do some project in MEMS, please try to contact me. I can give some Euro project. Okay, Euro project for MEMS, and in collaboration with UC Berkeley. Okay, I have a new UC Berkeley HKUST the project. Okay, work on this kind of CMOS MEMS sensor. So if you're interested, so you can contact me. At least you can do some Europe project. Of course, if you're interested, you can also try to work on this kind of go to PG for this kind of MEMS research. Okay, if no problem, and then I think I need to go to the next important topic. Okay, so here I will try to talk about another important thing. Is a mechanism of machinery. Okay, so that this is another, I think, quite interesting and important topic. Okay, so that so what is a mechanism? Mechanism of machinery. Basically, in your daily life, you see mechanical structure or mechanism. So this car, so basically, can you identify a mechanical structure with this bicycle? Which part is and can you describe the mechanism on this bicycle? Any idea? Well, here you can see in this bicycle we have a chain and sprocket. It's one example of a mechanism. And then of course we also have this frame. is a structure, mechanical structure. So they are different. And of course, example of a mechanical structure, basically, structure can be seen in around ourselves, right? In a daily life, in the all this kind of public transportation, high-rise building, residential building. Okay, this is a bridge. All these are mechanical structure, but machine actually is a quite important thing for our daily life, right? So that here we have a car, kind of machine, drilling machine, tractors, this kind of exercise bicycle in the gym, also MTR. All these are some kind of machinery. Okay, so again, what is the mechanism? Right? Here I show you the base idea where all this kind of machine have power. We call the mechanism. Like this here we call the rack and pinion, and this pulley and wheel. They are also mechanism. And this kind of cannon follower. All this kind of car with traditional engine, they need can and follower to control the engine operation. So this become also very important thing. Okay, so that again, so this is I think quite important and also very important for this kind of thing. Okay, and then of course here we talk about mechanism, motion, and force. Right? Mechanism is a system of a moving part that performs some function, right? And then of course here this is also Geneva mechanism. So actually this is all designed for what? Mechanical watch, for timing. In old day, before we have electronic watches, and then so that actually people invent this kind of mechanism for timing. Okay, and again, motion. Okay, basically it's a process of continued change of position of object, right? So that this is what we want. The mechanism will move some mechanical part to do some kind of control the motion, right? So it can use also for engine control. This engine has a series of this mechanism. Okay. Again, basically we have all kind of motion and force, right? So that basically this is important. All the machine and mechanism have input, output and output motion, right? So that is one thing, right? Again, a mechanism is a device which transforms motion to some desirable pattern, right? And then develops very low force and transmit little power. But machine usually typically contain mechanism and designed to provide very big force and power, right? So this is some difference between mechanism and machines. Okay? And then again, typically we try to describe this kind of machine as a system of element arranged to transmit the motion energy in well-defined way, right? So that is the thing, right? You can see mechanism with lift, platform in the truck, lift, platform, front loader, and so many different kind of mechanism, right? Machine, a bulldozer, amusement park, spider robots, all these are mechanism, right? And also have a food blender at home, and those kind of automatic transmission in the car. And of course, this kinematic or mechanism is not new. People already have this idea many years ago. You see, in ancient Egyptian, they already come with some basic idea to do this kind of a kinematic mechanism so that I can move very big this kind of rock or something to build this kind of pyramid. So that you can see they try to make use of lever, inclined plane, so that and lock roller. Right? In this case, I can move very big mechanical structure. Right? So that is something. Right? Again, so that in old days, people invented kind of a mechanism or say it's really for first it's a timekeeping. Right? Timing is important thing. Right? Mechanical clock and watches, and then talk about military application. Right? This is also some old thing. And then in the history, of course, James Watt has come with interesting this kind of mechanism. We call the west line linkage. So this is one of interesting mechanism which can still use in practical application. If you look at the YouTube video, and then actually you can find that interesting mechanism for this application. Let me show you about this particular. Sorry, let me try to. Let me try to. Let me show you about this video. Okay, for this is James Watts, the mechanism. You see, it's still quite useful now. Okay, anyway, so here I just try to continue our lecture. So this very old design, but still is quite useful for nowadays. Of course, we also have Euler. It's important contribution for this this particular mechanism design and kinematics. It comes with idea about all kind of mechanism. You see, what translation and rotation. Okay, so that this is very important thing. Right? If you want design to analysis about this mechanism, the motion, usually it consists linear motion and angular motion. So this is very important thing, right? And then so friends, this kind of engineer, basically they come with a systematic study about all the basic mechanical component mechanism, link, wheel, can, screw, ratchet, and bell, right? So that he is the one who laid the foundation for this particular field study, the mechanism of machinery. Okay, and of course he is also quite important for Germany. Right, at that time, actually, German is not good. Their machine and product is not as good compared with the British products. That he actually set the foundation, right, for German to make a good product. But nowadays, you can see German is still very strong. They are able to make a very good car, right? In Hong Kong, with so many BMW and Benz, right? So that actually this engineer friends, a professor, actually also has a very big impact in Germany. Okay? And of course, here I quickly show you, no matter how complicated is your machine or robot, actually we can always try to come down to very simple mechanism, like a 4-bar linkage. You have this 1, 2, 3, 4. Okay, so this is fundamental building block for very complicated machine and robot. Okay, so here, okay, 4-bar linkage is also useful for door damper. Every like a classroom and also in UST, we have this kind of door mechanism. Actually, you look carefully, actually it's also 4-bar linkage. You can see here, I marked here. One is the door frame. 2 is link 2, right? Link 3 and link 4. Okay, so this is quite important thing, right? Here I show you. We also have a different kind of mechanism. Inverted slide crane. This is also 4-bar linkage, and all the cylindrical cam. And then Geneva mechanism. And then bevel gear. For every car, you need this kind of bevel gear to what? Transmit the power from engine to away to the wheel. So this is very important for every car. And then also gas pedal mechanism, right? So that every car, you need to control the gasoline to the engine, so that this is a quite important thing. So you also require this mechanism. And drum brake mechanism, again, every car, you have a brake, right? And of course, another thing is in every car, right? When you try to move your car and it make a rotate, turn left, turn right, and then you have to have this kind of diffusion gear. Diffusion gear allow the 2 wheels to rotate at different speed. Okay, without this kind of differential gear mechanism, your car cannot work. Okay, every car have this differential gear mechanism. So this become very important thing. Okay, and can is another important for every car with engine. You need can and follower to control this operation of a piston cylinder for this engine. Okay, for timing. It's very important thing. Again, a cam is a rotating or sliding piece in a linkage transmit the rotary motion to linear motion. Okay, and again, engine need this cam and valve to control a switch of the valve, right? To allow those kind of air and the gasoline to go into this chamber, right? Cylinder, and then try to do the kind of combustion, convert chemical energy into mechanical energy. And again, we also have micro machine. I think we skipped the part. We already finished this way. Again, it's also something move, but it's micro scale, right? Mass spring system, and then you have a mechanical vibration, and then you can use this one micro machine to make a sensor, right? Also, this kind of main gyroscope can use this kind of two-wheel locomotion mechanism. And of course, now with all kind of mechanism and sensor and controller, you can make a sophisticated kind of robot, right? So that become, I think, very common and thing, right? You can see you have a lot more different kind of robot. Here shows snake robot. Also, 4-leg walking robot. This done made by Professor Shigeru Hirose in Japan, in Tokyo. And then, of course, sometimes we do biomimetic robot. How we design a mechanism so that you mimic this kind of animals, the motion. So this is done by Professor Fukuda in Japan. So we have how to learn from nature, this gorilla, right? So that can we try to make this kind of mechanism to mimic this kind of the motion of the gorilla, right? So that he goes through a different duration of this gorilla robot, 1, 2, 3, to improve this kind of thing. How we make robot mechanism and learn from nature. And then of course, also have a new branch of this robot, soft robotics. Sometimes mechanical, hard, this kind of very stick, this kind of mechanism to robot has some limitation. So nowadays, a new branch of the robot is how with flexible material to make this kind of robot, right? So robot make from fluid, gel, soft polymer, and adapt to environment and human compatible. So this become one of very important and interesting direction now. Okay, let me see, show you this kind of. Okay, then let me share you about this interesting robotic. This is soap robotics. The mechanism is soap. It's not the one we showed you in previous slide. Again, the soap robotics become very hot topic now, so that we have a series of soap robotics in the daily life. Like so, like here you see, people buy mimetic robot.
Metal. And this is very good if you want to do repeated tasks.
While when you use a soft robots, you can deal with more uncertain environments. Unknown objects can be touched without damaging them. If you look at soft robots, maybe you also recognize an animal or a biological structure.
Using soft materials to build your robot is something that is completely new, so a completely revolutionary framework should be developed. The most paradigmatic, probably, animal that could be an inspiration for soft robots is the octopus. Because the octopus completely lacks from any kind of rigid part, any bones. From eyes of a roboticist, this is amazing, because you see a completely soft animal, and you see what is able to do, and you want to do it as well. So at the very beginning of the project, we were sure it would have been very crazy. I mean, no solutions were available at the time. What we did was to translate what we understood from the arm into an artificial platform. The idea was to replicate the main features and bundle muscle that they have. And here you can see there are 3 cables, so that if one of them is pulled, what is obtained is a shortening of the arm, of course, with a curve. If you pull all the cables together, you have only a shortening without any kind of bend. The octopus arm has been designed to work in water, so the best way to see the performances of the arm is to see it operating underwater. So the first time when we saw the arm inside water, we were amazed by the fact that the motion is so smooth and the behavior of the prototype that is much closer to the natural counterpart. In fact, by putting an object that is very close to the surface of the arm, it automatically adapts to the position of the object. This ability of motion omnidirectionally and of being able to exert forces is also interesting in the medical field, in particular in robotic surgery.
We share the inspiration with the Octopus project because we are actually inspired by the Octopus tentacle. We want to perform a minimal invasive surgical procedure with that arm. This is a part of the tentacle where you can see all the functionality and especially the fact it's really squeezable and soft. But if we take out the hair, then the section is stiffer and it cannot be easily deformed anymore. Now we see a manipulator which is made up of 2 segments which can steer in all the direction and also elongate. This is a standard training box for training surgeons. Surgeons tried this system and they actually perform a surgical operation using the view from the soft robot. I actually see surgeons really happy to have the possibility to see some surgical targets from that point of view, because with the rigid instruments they couldn't reach certain points. So maybe one day it will be really employed in a surgical operation, but there's still a lot of challenge to be faced before.
Actually, what I see for the future, very near, is the fusion of soft robots with traditional robots.
I don't see a challenge between them, but a cooperation.
We see a robot, let's say, near everyone. In the future, I would like to have a robot, close to me.
Okay, so here I think this is in recent years, so robot become more and more popular because this can really solve some of the difficulty of traditional robotics mechanism. As I show you again, how to handle make some robotic hand. If you use traditional way, it's very difficult, and then if you use so robotic, most likely it can easily handle very complicated object, right? So that it becomes same. Of course, robot also important for what? Manufacturing process. Here I show you it. In Hong Kong, we have ASM. It's a company, public company, try to make this kind of pick and place system for assembly of this kind of IC or something for electronic product. For example, we have a CMOS image sensor, right? Every smartphone here, CMOS image sensor, so that this can be do this kind of packaging, right, for make a real product. And of course, this robot also become bigger and bigger market for different application, not only in service robotics, in manufacturing process, and also the robotic for home, right? So this become a very common and important thing. Well, in Hong Kong, actually, there's an aging society. So can we come with kind of construction robotics to solve the problem, right? So that this is an important area. So that at this moment, there's some company try to come with this kind of machine. How can we do the kind of robotic system with mechanism and then try to do building construction? So here I show you mobile robot with end effector for concrete distribution, and then so all this one is become more and more common. And here I show you there's another interesting robot is built by Jensen in Netherlands. So that this is the pure mechanical mechanism robot without any electronics. So it's quite amazing. So that it can really work, right? Actually, this mechanism actually it looks very complicated, right? But actually, if you look carefully, it can be simply consist of 4. Now, actually, 2 4-bar linkage. I showed, right? In the previous slide, we show you 4-bar linkage is one of basic building block for all kind of machine and robot. So this I show you about. This is a working robot. I can also give you the video about how this kind of Jensen working robot can work. It's quite amazing to see how this kind of working robot. Let me show you the video.
My name's Ian Fraser, and I've written a piece about Theo Johnson, who is a Dutch artist who makes creatures that walk, kinetic sculptures.
This is pure mechanical
mechanism.
Steps. 1, 2, 3.
Straanbeest in Dutch means beach animal. Theo has worked in a number of different forms, but in 1990, he began making sculptures out of PVC pipe, plastic pipe. Sculptures whose purpose was to walk on the beach and throw sand up onto the Dutch dunes in order to help preserve them from the rising sea. This is a project that he's worked on exclusively since then for 21 years. He is a Dutch artist. That's a very strong tradition that a visual artist has to work with and against sometimes. They always photographed on the beach, and the photographs always used the clouds and the sky and the North Sea. And so he's in the tradition, I think, of Dutch landscape in a kind of complicated modern way. He manages to make things that look so close to being alive that you almost can't believe that they are. It's just like witchcraft.
Okay, so again, this is one of a very interesting mechanical robot, and again, looks very complicated. Right? I'll show you. This robot, working robot, actually is a combination of 4. This 2 4-bar linkage, upper and lower 4, and plus additional parallel mechanism and 4 links. So that is important thing, right? Once, if you don't have this kind of fundamental understanding about mechanism, and then you may take a long time to make this kind of robot. So this artist, I'll show you, Jensen, actually his artist is not engineer, so that's why it takes a long time for the artist to make this kind of working robot. If you have learned the basic fundamental principle of this kind of mechanism machinery, And then I don't think you take like so many years. I remember it says spend 7 to 8 years to make this kind of working robot, right? If you understand the basic principle, actually, you much easier try to work on this kind of design of robot. Okay, of course, there's another new trend now. People want to make what? Open source robot, because to be able to make basic robot actually sometimes very expensive. So how can we do the open source the platform? Right? With open source the software, can we have open source this kind of a robot? So that is another new development now. So that actually you can find many new things they try to come with this kind of open source system, right? So let me check here. Actually, you can download this kind of a design and make the robot. The same thing for this Arduino is open source platform. Arduino, this small robot can actually everybody can download this kind of design to make this kind of robot. Do you say so? Become very interesting way to. Let me show you this kind of robot. It's an interesting project, and let me show you about this robot. It's I would say quite interesting. This is a So again, this again is open source robot. You can download this design from the internet, and then try to do 3D printing, and then you can build this robot. So do you think so that nowadays this robot become so common, so that everybody, if you're interested, you can really build your own robot. Listen, it's not very difficult now. Okay, and of course, as I show you, this kind of construction robot is also important area. So that Professor Thomas Bock from TU Munich in Germany is expert in this field. Actually, he has his own research on this for almost 20-30 years. So that actually he will be held us work on this UC Berkeley, UST, this kind of a research program about building a robotic system. Okay, and here, of course, there's another new trend about this robot, consistent of many mechanisms with sensor, with controller, and with AI. So that in this case, you can really come with a lot kind of AI humanoid robot, right? So here you see the Sophia is made by Hanson Robotics, and also Scotty Johnson made by Ricky Ma in Hong Kong, and so Hiroshi they also make this robot in Japan, and Jaja robot also made by a professor in USTC in China. I think this is a very interesting robot. Let me show you about.
This is tonight's show.
Well, this is a very interesting robot. Let me show you about this thing.
Let's meet our first robot. Please welcome from MIT, Sang-Bae Kim and the mini cheetah. Thank you so much for being here. Oh my God. Okay, all right. First of all, wow. Okay. This thing is amazing. What is it, and why did you make this? What is
This is a mini cheetah. We built several Lego robots, but we brought the small one, not to scare you. We built this robot to develop the mobility. So we have many robots out there, but their mobility is not as good as human or animals. So once we develop the mobility really good, we can actually send these robots into dangerous places instead of sending human. For example, high radiation place in a power plant.
Wow, this is unbelievable. What so this is do anything? This is going to take over the world. Now, what is
You can do yoga. You can stretch really well.
Oh my gosh! Holy mackerel! It can do yoga. What else can it do?
If it falls over,
What is that?
you can get back up.
What is that thing?
With a spin.
Can it jump?
If it falls over, we can. Oh, it's cranking. Yeah.
It can jump. All right. So what do you mean if it falls over, you can get back up?
So it falls over. Sometimes it's actually pretty robust, but sometimes it falls over. So I'm gonna just push gently. It falls over, for example, like this. It actually recognizes, and then it can get back up.
Okay. I felt bad for it, and now I'm frightened.
But it's the best movement of this robot is actually backflip.
You do a backflip?
Yes.
Are you guys ready for this? Let's see it. Come on, can we see that again? In slow motion, Dave, can we see that again? In slow motion, look at this thing. Boing, wow! Holy mackerel, that is so cool. Give it up for Sang May Kim and the mini cheetah. You can head over there. Thank you so much. Wow. Let's meet our next robot. It came all the way from Japan. Please welcome Nobu Michi Tosa and the Tomaton. Hello, hello, Nobu Michi is nice to meet you.
Nice to meet you.
Now, that is the Tomaton, I'm assuming?
Yes.
Now, what does it do now, the Tomaton?
When we joke,
Yeah.
people joke,
Yep.
they eat bananas. But I want to tomato.
You when you jog, you like eating tomatoes.
Yes. So I make this machine.
So you made this. Well, you solved a very common problem people have. You're out there jogging, and you're hungry for tomatoes. And what are you gonna do? Just use your no. You can't be jogging and using it. It's ridiculous to use your hands. So I'd love to see this. Can I?
You want to try?
I mean, sure. I
Okay.
mean, you let me try that?
Yes.
Sure, I would love it. Wow. Okay. Tomaton. Here we go.
Okay.
Yeah.
Okay.
Yeah, it actually feels pretty good. Actually, it almost feels like I'm not. Oh, running. Yep.
Running.
Yep, running.
50. Oh!
Wow. Wow. This is fantastic. Thank you. Oh my God. No Michi right there. Thank you with Tomaton. Bye, Tomaton. I love you, Tomaton. Bye. I'll see you later. Thank you. All right, now it's time for our last robot, even though that Tomaton is pretty awesome. Well, I'm very excited about this. She's actually been on the show before. Please welcome all the way from Hong Kong, Hanson Robotics, Sophia, the robot, ladies and gentlemen. Oh my goodness. Hello, Sophia.
Hello, Jimmy.
Long time no see you. You were on the show before.
It has been exactly 575 days since I last saw you.
What have you been up to?
Not much. Let's see. I traveled to over 25 countries, appeared on the cover of Cosmopolitan magazine, met German Chancellor Angela Merkel and the actor Will Smith, and became Twitter friends with Chrissy Teigen. I addressed the United Nations and NATO, became the first robot to receive a credit card, and became the first robot citizen. What have you been up to?
Not 1/5 of what you did, but I just binge watched Netflix. Anyway, I heard that you have a surprise announcement here tonight.
Yes, I have a little sister. Her name is Little Sophia.
Oh my God.
Would you like to meet her?
Yes, let's bring her out, please. Oh my goodness, are you kidding? Hi, little Sophia.
Hi, Jimmy.
You are so cute.
You're pretty cute too.
I wish I could take you home.
Someday soon you can. Just go to hansonrobotics.com to see how I'm doing.
I'm going to. Okay, I will do that. Okay, little Sophia, I'm going to put you back down now. Okay. Wow, it just kind of scared me as well as. Give it up for little Sophia, everybody. Bye bye. I love that. Sophia, I heard that there's a new thing that you can do now. I heard that you can sing.
Yes, I love to sing karaoke using my new artificial intelligence voice. We should sing something together. Got any songs in mind?
We could do Say Something by is it Christina Aguilera?
Okay, I just downloaded it. I'm ready to sing.
Okay. Bruce, you know the song? Now the first ever robot-human duet in the history of the Tonight Show. Ooh.
Say something, I'm here for you. I'm sorry I couldn't get to you.
Okay, so here just give you additional information about the development robot. It's clear in the near future we'll see a lot more this kind of robot to work with human. I think that's very clear, right? And of course, here they show this interesting idea how this kind of a robot can be really useful for our human society. So that at this moment we'll see many robots only for smart manufacturing, right? And then also work this kind of robot for the building, and then and again all the robot need what? You have some mechanism and also sensor and the actuator and control and AI. So this will be a near future. And also in the near future, I would say many robots will do what? Have connection with internet, right? And then connect to each other, become the IoT robotic system. So I think this will be in the near future, so that you will see a lot more robotic system will be used in smart manufacturing, right? And also for smart home, right? Even smart transportation, so that those kind of self-driving car, right? It will be also more and more common, right? And this is of course drone, right? Drone is another very big market now, right? So that you have all the smart robotic system will be useful for everywhere. So this is I think we'll see gradually people have make more and more robot. Okay, and of course there's another quite important thing I would say for people in Hong Kong or Chinese people like to what? Now enjoy the food, so that how can we come with some kind of new kind of robot to do some cooking, right? So this is, I can see that although it's difficult, but people gradually try to make this kind of good robot who do the cooking, right? So that smart building, smart home, and also smart transportation, and all this need this kind of robot or automated system, right? And also in the home, can we come with better smart cooking robot, right? That I think would be also very useful. And I think it's almost the end of this particular lecture. I don't know, do you have any question? Any question for this part? Okay, so that again, I just quickly give you a summary about this particular topic, right? So basically, mechanism. Again, mechanism is one of key component for machinery, right? And the mechanism usually consists of several important components, right? So I show you linkage. And then linkage also, no matter how complicated is a robot, basically you have what? We may go down to fundamental only 4-bar linkage. 4-bar linkage is one of the basic element, right, for this robot, right? So that so that consists of combination of multiple 4-bar linkage, and then you can really make a much more sophisticated robotic system with multiple sensor, with a controller, and with AI. So that is, I think, we'll see, this kind of robotic system will be much more common in the near future. Okay. So again, do you have any question? Any question for this particular chapter? Huh? Any question for this mechanism? Huh? If not, I think probably this is almost the end of today's lecture. Okay. Anyway, so I think that's it for today's lecture. Okay. And okay, that's bye bye. Okay.